Hello guys, so today we are here to solve the weekly contest 419th first challenge. In this challenge we are given an array and we need to find all k-long x sum of all k-long sub-arrays. So in order to understand this problem we first need to go through this problem. Unless you understand the problem we'll not be able to solve it. So to do that we will first go through this problem, and this problem is it's telling that we are given an array nums of an integer. Okay, so we are given an array nums of an integer and two integers k and x. So as an input we are given an array nums of an integer. Nums contains n integers and two integers k and x. Now we have to find x sum of all k long subarrays. So what is x sum? So x sum is, here in this line it is mentioned what is x sum and how we can calculate the value of x sum. See, this problem is telling how you have to do it. What is the procedure to solve this problem? This problem statement itself is telling the x sum of an array is calculated by the following procedure. It's laying down the procedure that count the occurrence of all the elements in the array. So x sum of an array, the whole array, keep only the occurrence of the top x most frequent elements. If two elements have the same number of occurrences, the element with bigger value is considered more frequent. Calculate the sum of the resulting array. And also it is mentioned that if an array has less than x distinct elements, then its x sum is the sum of the array, all the elements in the array. Okay, now the last line says that return an integer array answer of length n minus k plus 1, where answer I is the x sum of the sub array. So we have to find the x sum of the sub array and put it in the ith slot. So I plus k, see last value is I plus k minus 1, last index is I plus k minus 1. Okay, so last index is I plus k minus 1. It means the subarray ranges from I to less than I plus k. Last index is I plus k minus 1. It means it is less than the last index is, the I will be less than I plus k. And we have to find the answer and put it in the result array. So I hope this is clear, and now let's go to the problem statement. And in the problem statement we are given a class called solution. Okay, and then the function is find x sum, which we have to complete. And as I mentioned that we'll be given three inputs, array nums, int k and int x, and we have to return a result array. Result array is of length n minus k plus 1. This is already mentioned in the problem statement. Okay, this is already mentioned in the problem statement. Return an integer array answer of length n minus k plus 1. This is already mentioned. Okay, this is already mentioned that return an integer array of answer of length n minus k plus 1, where the ith entry of the answer is the x sum of the subarray I plus k minus 1. I plus k minus 1, it means that last index is I plus k minus 1. It means I is less than I plus k. Okay, this is the boundary of the end boundary of the subarray. Okay, so with this thing clear, now let's try to solve this problem. In order to solve this problem, what we'll do that we will just concentrate on this, and then what we'll do. Okay, so first thing that we have to find what is the length of this array, because the result also depends on this length. Okay, and it was told that return the answer. Okay, so we'll be writing int answer and then new int array. This will be n minus k plus 1. The length of this is n is the total length of the array, n minus k. So we are going till the kth value. See, n minus k means from 0 to k there will be n minus k indexes, but the total count will be plus 1. Okay, because we are including the value from which we are starting the count also. So n minus k plus 1, and now we have to find the we have to iterate over this answer array, and to iterate over this answer array we'll go through like this. I is less than answer dot length, we can say, or what we can do here that we can take this value. Okay, and then we can declare one more variable over here, answer length is equal to like this, and then we can put this answer length over here, and then we can use this answer length, okay, and then plus plus I we can do. After doing this, what we will do, we will see, we have to iterate from I to I plus k minus 1. So we have to consider subarray, and to consider the axiom of that subarray, we have to declare one int array frequency. Okay, this will be giving us the frequency of those elements. And also, if you remember, this problem is telling that there is one constraint in this problem. The constraint is that each value is in between 1 to 50. Okay, and n length is also between 1 to 50. Okay, so these are some of the constraints in this problem. Okay, since the individual values of frequency is in between 1 to 50, the int array will be only in between this 51, like this. Okay, int array will be only in between new int 51. Okay, and now what we will do, that we will go through this array. Okay, go through this array, and we will start our count from with j is equal to I. Okay, j is equal to I, j is less than I plus k, because the last index is I plus k minus 1, so j should be less than I plus k, and then plus plus j is the thing. After this, what we will do, after this we will find what is the frequency. So frec of nums of j, whatever is that value is, will be incrementing that count. Okay, so this will be giving us the count. After this, what we will do, now we have the frequency of the elements. Now we have to find which one is the we have to find the axiom, and to find the axiom we have to find the occurrence of the top x most frequent elements. So we have to find the most frequent element. To do that, what we will do, that we'll create one two-dimensional array, and frec element, so frequency with the element will be there. So it will be two-dimensional array, and it will be of the same size. New int array, it will be 51, and second value we don't know. Now what we'll do, for int I is equal to 0. Okay, less than 51, because there are total that many values, and then so we will not use I here. Again we'll go back to j, because I is the outer index value. So we'll j, and then again plus plus j. Okay, now in this what we'll do, frec element of j is equal to new int array, and this will be frec of j, and then j, like this. So after this, what we will do, we have got the frequency of the jth element, which is paired with the j, and after this what we will do, that we need to find the most frequent. To find the most frequent, we have to sort it and get that most frequent at the at one end of the array. So to do that, we'll use arrays.sort method, and then we'll be passing this frec element, and then inside this we will be passing comparator dot comparing int, and in this we will, since this comparing int we are having, the arrays, so we will be having this int array a, and first of all we'll be doing this in the reversed order. I meant to say the reversed order of the frequency. So frequency is the 0th index, so we'll be doing this reversed. Okay, and if in case two frequencies are matching, okay, then we'll have to, then we have to do the sorting comparator dot comparing int, and in this again we'll be passing this int array a of the element itself. The element itself is the first index, and that we need to, that also we need to do reversed. Why? Because the bigger element will be, it's a descending thing, so to get the descending behavior we have to do this. Okay, and after this, this is the thing that we need to do here. Okay, and then what we will do that, we have got the top most frequent most frequent elements. Now to get the final sum value, what we'll do that, we'll take this int sum is equal to 0 for int I is equal to, not I, j is equal to 0, j is less than x, plus j we'll have to do, and then we'll have to do sum plus is equal to frec element of j and 0 into frec element of j 1, like this, and this sum will be going into the since we are, the outer loop is going through the array, so a and s wer of I is equal to sum, like this, and then we have to return a n s wer, like this. Okay, and after this we will run this. Comparator, and maybe we have to include this in parenthesis, so we'll have to include this as well. I guess this declaration is not necessary int array, but it's better we do that. Find symbol comparing int method, then them, not then, it's then, not them, then comparing. Perfect. Now I wanted to have this thing that whether this, just be passing a also, it should work. I mean to say the compiler should pick this thing from the context, infer this from the context, because Java is very, powerful language. No, so we have to declare this int array over here. Okay, like this, like this, like this. Perfect. Perfect. So this is the way to solve this problem. You see, uh, we are using arrays as much as possible. Here we could have used, here we could have used a map, but we avoided that. Here also we could have used a priority queue, okay, but we avoided that. Why? Priority queue, but we avoided that. Why? Because dealing with arrays is always faster. Involving any collection class in any simple solution will unnecessarily add time complexity on your solution. If you know how to play with these things, then you can definitely get you know much faster performance. And try to avoid collection or STL classes as much as possible. um, Try to use simple things in your solution, and that adds more power to your approach. I mean to say, if you are able to do that, nothing like you. To me, we could have. The first way I solved was using map and priority queue, and I did all those things. But to me, this solution looks much better than my initial solution. So I hope you like it. With this, I would like to thank one and all. Happy coding, best wishes.